Okay, so here is section 6.2. X to the 1/9 power. What they want me to do now, so we're in the same chapter. Now we're going to connect fractional powers with roots. Do you know they have a relationship? So at this point, a lot of this course has been review. Probably you've seen it before. At this point, we're probably starting to break into new stuff that you haven't done before if you've had Math 201. So it turns out here's the official rule. In fact, let me just give you the rule. Here's the official rule. If you have a fractional power, let's say a over b power, the denominator, that b, swings around into the hook and becomes, they call it the bth root. Sounds weird to say. The b that's in the hook, the bth root of x to the a. That's the rule we're going to use again and again and again and again in this section. That's the main attraction right there. Let me let you copy that down. So that's the rule. And so that means anytime you have notice what it says. It says the number at the top just stays there. See how that didn't go anywhere? X to the a, x to the a. That didn't go anywhere. It's only the denominator that went somewhere. He swung into the hook. So you can go either way, back and forth, and they're going to have us go back and forth both ways in this section, depending on what's more convenient at the moment. So it's something they do a lot of in higher math. Just an hour ago, I was talking about this very rule with my pre-calculus students who are headed on to calculus next semester, and I was telling them, when you get to calculus, you got to do a lot of this, and I was reminding them, many of them had forgotten about this rule that you're seeing right now. So anyway, it's a rule used a lot in higher math especially. So fractional powers become roots. So, getting back to it, they're saying, so take this fractional power, that's way up there, isn't it? Let's put it like right there. So, and they're saying, convert that now to a root kind of thing. Well, how do you do it? The 9 swings around, becomes the 9th root of x to the 1. That's what they want you to put over here. 9th root of x to the 1. And that, yeah, I'll just leave it at that. The 1, you don't need a 1 power. Huh? You can just get rid of that because plain x means x to the 1. You can just get rid of it. It's the 9th root of x. That's what they want you to type in. You have a way up when the palette appears, there'll be an option for putting numbers in the hook. And so you put that 9, whoops, I just erased it. Put that 9 in the hook. There it is. Let's try the next one. 16 to the 1/4. So, the 4 in the denominator is going to go where? Into the hook, like that, huh? Now, what's the answer to that? Yeah, the trick is it's a 4th root. It's not a square. It's not a 2 root. It's asking what number times itself 4 times is 16. What number times itself 4 times? So let's take a guess. Let's start with 7. And go 7 times 7 times 7 times 7. It's way too big. And you go, oh, maybe 3. 3 times 3 times 3 times 3. And I can do that one. That's 81. Way too big. It's supposed to come out 16. Then you say, well, how about 2? 2 times 2 times 2 times 2. And that's it. Ding, ding, ding. So the answer is 2. That's the number times itself 4 times. That is 16. Is that making sense? That's what a 4th root asks. Yeah, I'm hoping that kind of makes sense for you. Because normally we take a root of something like 9, and we say the answer is 3. And why is the answer 3? Because 3 times itself twice. 3 times 3 is 9. But now when you put a 4 in the hook, you're saying what times itself 4 times? Is that good? All right, let's keep going. What do they want me to do on this next one? Rewrite without, rational means fractions. Exponents or powers. So they want without, no fractional powers, please. So they want me to get rid of that fraction that's up there in the power. You tracking with me? Rewrite without rational exponents, with no fractional powers. So how do I do it? What do I do with that 1/3? Just swing it around, right? That 3 is going to come into the hook. Third root of a squared b squared. You don't need that 1 power. 1 power is understood. Right? 1 powers don't do anything. So just the 3 swings around into the hook, and we're done. That's the answer they want. Do you see what we're doing? We're just practicing using that main rule that when you have a fractional power, the denominator swings around into the hook. And just writing it that way. That's all they want me to do. How about number 4, which has an 81 to the 3/4? How could we rewrite that one? The 4 swings around. Good to there. And now, what are we going to do with it from there? That's ugly, isn't it? Any ideas? What times itself 4 times is 81?
So you disregard the third power?
No, I'm going to do that later.
Oh, okay.
Even though it looks like it's first, you can actually do it later. It's easier that way. What's the 4th root of 81? What times itself 4 times is 80? Take your calculator if you're not sure. Just take a guess. Just take, maybe it's 7. 7 times 7 times 7 times 7. Way too big. What times itself 4 times is 81? 3 times 3, right? Because 3 times 3 is 9, and 9 times 9 is 81. So the answer is 3, but like Claudia said, what about that third power? We can't forget that guy. Does that make sense what I did there? I just did the 4th root of 81. That came out 3, but I still got to do the third power. So third power is 3 times 3 times 3. The answer is 27 to this one. How are we doing? Am I losing you?
For the first 3, you have the 3 in the hook. You don't do anything with that because it's
letters, yeah. Because on number 3 it's letters, I can't really work it out any further. They just stop right there. But when it's numbers, yeah, good question, exactly right. When it's numbers, you actually go on and work it out to get a final number.
So on number 2, you did the 16 square root of 1 because that's 1, but usually you would take that route, you would do the...
Say that again? What did I do?
Number 2 you did, so 16 square root of... It's
4th root of 16.
Yeah, you did...
Came out 2.
And then, so do you usually just, would you take that route first instead of doing, like Claudia was saying, for number 4? Disregard the 3, the 2 first?
Yeah, right. So I did the same thing on 2 and 4. Right? I let this 4 swing into the hook, and then I asked myself, what times itself 4 times 16? 2. I did the same thing, let this 4 swing into the hook, asked myself, what times itself? Yeah, so I ignored this 3 power. Yeah, you could do the 3 power first, but it's way harder. Because 81 to the 3rd is gigantic. It would work out the same in the end, but it's way harder.
Okay.
So I do the 4th root of 81 first, which comes out 3. Then I do the 3rd power afterwards on that. That makes sense? Now, having said all that, let me give you an easier way to do number 2 and number 4. Just you can do them straight on your calculator. Now, it's going to depend. For some of you that have the backwards calculator, it's not going to be the easiest thing in the world. But you can do it. I just want to give you a warning. It's going to be a little tricky. For those with the nice calculators that do everything in forwards, all you got to do is just take 16 and you have a power button. On some calculators, it's like, I don't know. On the Casios, it's x to the blank up here like that. You do 16 x to the blank, and then you put the 1/4 in the blank, and just hit enter. It'll get you straight to the 2. Same thing on number 4. It'll get you straight to the 27 if you just type it in just like it looks. I mean, that's why the Casio is so nice. Natural display. It looks just like it does naturally. Just type it in, you'll get right to the answer. Just straight out. Now, on other calculators, it's a little different. All right, so it looks like we're all on board. You can do those directly. So if it's pure numbers, like number 2 and number 4, pure numbers, just use your calculator. Okay, so try number 5 straight on your calculator. I think, is it 3625? 3125, okay. See if you can get that answer on your calculator just straight. 25 to the 5 halves power. That coming out okay now? So if it's just pure numbers, you can just directly do it on your calculator. On that. Good, okay. Now, coming on down to number 19, or number 6, which has a square root of 19. They want me to, let's skip it. Let's go down to number 7, and we'll come back to 6. I'll show you why in a minute. So number 7, they want me to go the other way now. So now I'm going to go from a root back to just normal, fractional power, I should say. They're saying rewrite with rational exponents. That means fractional, right? Ratio is a fraction, one thing over the other. Powers. So they want me to turn it, they want like 19 to some power that's going to be the same as the 6th root of 19. So now they want me to use that rule the other way. So what you want to do is you want to say, okay, what's the power on the 19? I don't see any power. It must be an invisible 1 then, huh? So if there's no power there and you need to show a power, it's 1, right? If it's invisible, 1. So then where does that 6 go? Back to the denominator. It's 19 to the 1/6. And we're done. Does that make sense? So remember, you can go from the hook to the denominator, or denominator back to the hook, anytime you want, back and forth, depending on what they're asking you to do at the moment. There are 2 ways to say the same thing, like 1 and uno. We're saying the same number, 2 different languages. 19 to the 1/6, 6 root of 19, same amount, 2 different languages. That's all we're doing. Is that good? Now let's back up. If you're okay with that, I want to back up to number 6. What's the power on number? Yeah, there's an invisible 1 there, huh? But what's in the hook? I don't see any number in the hook. 2. How do you know it's 2? Why is it 2? Yeah, how do you do it? How do you do a square root? Like what square root of 9 is 3? Why? Because what times itself twice is 9. Right? 3 times 3 twice is 9. Not only that, do you realize you're saying it every time you say it? What do you call this? A what root? Square root. What does square mean? What do I say? Do we say this x 2'd? No. What do we say? That's x squared. What do we call when we put a 3 there? Cube. So square and cube are math's word, squared and cubed for 2 and 3, aren't they? So when you call this a square root, do you realize you're saying 2 root? One of those things we say and don't realize we're saying, huh? You're saying 2 root. So then where's the 2? It's in the hook. It's the only understood 2 I know of in math. If you write nothing in the hook, you mean 2. Why do they do that? Why do they do these invisible numbers? Well, they just got lazy over time. It's like any field. You know, if you do something a million times, that's usually the same thing. After a while, you say, look, if I don't write anything, I mean 2, okay? I'd rather not write the 2. That's just what happened over time. They just did 2 roots so often that after a while they said, if I don't write anything, I mean 2. That's the one that's used 99% of the time. So, and we're saying it, square root. Yeah, so having said all that, there's an invisible 2. So where does the 2 go? Into the denominator, huh? So that's 19 to the half, and that's the answer they want on that one. Bless you.
Thank you.
Is that making sense? So whatever's in the hook swings back into the denominator, doesn't it? And if there's nothing in the hook, that means there's a 2. And if there's no power showing, that means there's a 1. So we have an invisible 1 and an invisible 2, don't we? Invisible 1 is the power. Invisible 2 if there's nothing in the hook.
And it's always true for these, there's always, when it's just the square root.
Yeah, when it's just the root with no number in the hook, it's always 2. Yep, exactly. Okay, so number 8. So same kind of thing. They want me to rewrite with rational exponents. So what am I going to do with that 3 that's in the hook? It's going to swing around, yeah, to the denominator. So that's x, y squared z. Yeah, you got to put parentheses because you want it. Why? If I left off the parentheses, everybody see where the 1 came from? There's no power. It's an invisible 1, huh? Why would it be wrong to write it that way without parentheses? What does that actually mean that's a different meaning? Only pertains to the z. Yeah, that would be only the z is to the 1/3 power. But all of them were under the root, under the third root. So that means all of them have to be raised to the 1/3 power, huh? All of them raised to the 1/3 power. Good. How about the next one? You do number 9. Yeah, right. Good question. We're removing the root. Yeah, when you swing that number around, the root vanishes. Yeah, I should say that. Good. Yeah, we are removing the root. The root is vanishing when we swing the number around. All right, so so what's in the hook on number 9? 2 swings around. So 3mn to the power 9/2. Is that okay? Like that? That good? So the whole 3mn is raised to the 9/2 power. The 2 swings into the denominator. Again, the root vanishes, doesn't it? We no longer have a root. We're out of the root language, and we're into the fractional power language. And you got to put parentheses, because that way you say the whole 3mn is raised to the 9/2 power, not just the last item, the n. You do number 10. Same kind of thing. So 2x to the 6y. That 11 swings around. All raised to the 3/11ths. We good there? Number 11. Okay, we're going negative now. Things are changing. All right, yeah, we need to talk about that. Let's go over here. I don't know if anybody remembers. What does it mean, like if you have a number like, I don't know, 7 or whatever, to the -1 power? What in the world is that? Or let me just do an x. How about x? Nagak, what is it? 1 over it, yeah. Negative powers flip things. Do you remember that rule? That's a weird rule. So negative powers flip. They flip it. So, and then the power becomes positive. So negative powers flip, then the power becomes positive. So like if you have x, come down here, like if you have x to the -2, what will that do? It'll flip it, and then the power will become positive 2 or regular 2. Does that make sense? Negative powers, when you have a negative power, it flips it, and then the power becomes positive. I always make the analogy, it's like somebody that's unhappy at their job. They jump to a new job, it jumps to the other side, and then the power becomes positive. Then it's happy at its new job. So they're negative. They're unhappy. So negative powers are negative. They're unhappy where they're at. They want to jump to the other side of the fraction, and then they become happy. Then they're positive after the jump. So, like, how about the next one here? Like, what if it started on the bottom? What if you had 1 over x to the minus 3? What if it starts on the bottom like that? Where's it going to go? It's going to go up to the top and then become positive. Like that. Get the hang of it? So negative powers are negative. They're unhappy where they're at. They're always going to jump to the other side, and then they become positive. Then they're happy after the jump. All right. So let's get back to the question then. So, I would actually, since it's just pure numbers, just do it on your calculator. If you want. Can you just type that into your calculator? Oh, wait. No, they're not going to let me do that, are they? No, they want a fraction. You might not be able to get a fraction. Depending on your calculator. Yeah, some of your calculators. Well, you'll get 0.5, which is a half. You guys able to get that in your calculator? Yeah, let me never mind. I mean, that's true, but I don't think that would be easy way. Let's do this. Negative power. So what did we just talk about with a negative power? It flips, huh? So it'll go underneath a 1, and then the power will become positive. And then I would just do this on your calculator. Once you have it flipped, and you'll get 2, so the answer is a half. Let me let you get that. See if you can get. See how the power was negative? And then after it flipped and jumped to the bottom, it became positive. Like that. So the answer is a half. Is that okay there? And then you just do the 16 to the 1/4 power using your calculator. We'll try number 12. Okay, are we okay with number 11? Okay, 12. Again, what do we do with negative? Notice the power is negative. So it flips. It jumps to the bottom of the fraction, and then the power becomes regular, positive, just regular. 3/4. And then hit the buttons on your calculator, I think. Is that what it is? 1/64. You guys able to get that okay? Okay, so now it's 9. They put that up so high. 9x to the minus 1/3. Basically, there's nothing to do in our calculator, because we have ladders now, we can't do that in our calculator. So what they want me to do is basically just apply the rule. They're just going to keep testing me if I know the rule. And notice what they say, rewrite with positive exponents, positive powers. So they want me to do the negative power rule. So all they care about is this negative right there. And what do negative powers do? They're negative, they're unhappy. Flip. Now, so don't write this down because this is wrong. But that's what it's tempting to do that at first. I'm sure I did it when I first learned this stuff. What's wrong with it? Why didn't I do it right? Didn't I flip it down and then the power became positive? It's close. It's almost right. I made one tiny mistake. Yeah, that power's not on the 9. The 9's going to stay up in the top. Everything else is good. That's the right answer. So it makes sense what happened. That negative 1/3 power is only on the x. How do you know? Because there's no parentheses. If there was parentheses, then he would flip the whole thing down below, because he would be the power for everybody. Right? So there's no parentheses. So that means that power, that negative 1/3, is only on the x. So a negative power, remember, jumps to the other side, and then the power becomes positive. So that negative 1/3 power jumps it down to the bottom, and then it becomes positive. And we're done. That's all we can do, because it's just an x. We can't calculate a number or anything. It just what did we do? We made it be a positive power. Huh? See how it's a positive power? That's what they said. Rewrite it with a positive power. So we did. Can you do the next one? Now that minus 2/5 is on the whole thing, isn't it? In fact, you can see the options, huh? Can you just tell by looking which one it is? Or we could do it. We probably shouldn't work that way. Maybe not the best way. Yeah. So that negative, now the negative power is on everybody this time, huh? So everybody's going to jump down, and then the power becomes positive, huh? Because negative powers are negative. They're unhappy where they're at. They want to jump to the other side, then they're happy. Want to jump to a new job, then they're happy. So yeah, it is C, isn't it? Questions on that? 15. Same kind of thing. Rewrite with positive powers. So anybody that's negative has got to jump. So who's got a negative power there? B. Yeah, just the B, huh? So everybody else is going to stay in the top, and just the B with his power, his -5 has power. Just that piece will jump to the bottom and then become positive. So it'll be 6A to the 3/5, C to the 4/3, and then, and then the B will jump down and become positive 5/2. And we're done. Is this making sense with these negative powers? They're just negative where they're at. How about number 16? We have a negative power on a fraction. Notice that negative 4/3, that negative power, is on the entire fraction, isn't it? It's not just on the 2 or the x or the bottom, it's on everybody. So that means, and it's a negative power, so that means it's going to make everybody switch. So it's going to flip the whole fraction. Does that make sense on that? So that'll be 7y z on the top, 2x down there, and then the power will become positive, and we're done. Just like that. How we doing? Is that making sense there? So a negative power flips it to the other side. Right? Because everybody jumps to the other side, and then the power becomes positive after the jump. So getting the hang of that. So negative powers, whoever they're on, and they're on everybody this time, jump to the other side, then the power becomes positive after that. All right. We'll keep going if you're good. Okay, let's try that one. Same thing. They want me to make the powers positive. So this negative power is going to jump up to the top. Huh? It starts on the bottom. It'll jump to the top. Become x to the positive 2/3. Now you can put it over 1, but we never leave 1s in the bottom of a fraction. Why not? Why don't we leave 1s in the bottom? Because that's considered unsimple. Like think about 7 divided by 1, for example. That's just 7, isn't it? Because 1 goes into 7 times. So you never leave 1s in the bottom. That's considered unsimplified. You just get rid of them. Just a normal 7. Anyway, that's not our question. This is just normal x to the 2/3. Don't need the denominator anymore. All right. What about, okay, now number 18, I want you to notice something. That right there, well, first off, these two are negative powers, aren't they? So those two are going to jump to the bottom, whereas the x to the 5th will stay in the top. Is making good sense? So the x to the 5th stays in the top. The 8 and the y jump to the bottom, and their powers become positive after that. Is that good so far? And now, this is pure numbers, right? No letters, that piece. So grab your calculator and crank that out. I think it'll be 4. So there's our final answer. Is that good? Questions I can answer on that? Vincent? Yeah, that became 4 by the calculator. I just did 8 to the 2/3 part. Depending on your calculator, some people need to put parentheses around that 2/3. Somehow do it, depending on your calculator, and that should come out to be 4. And so the negative powers jump to the other side and become positive, and then anything that's pure numbers, we just do on our calculator. The letters stay as they are. 19, I think we're getting closer here to getting done with this section. Number 19, they want me to rewrite with positive rational. You can see the multiple choice answers. In other words, rational means fraction, right? Ratio, one thing over the other. So they want me to rewrite this as something that has fractional powers. So how do I do that? What is that 4 here? Let me rewrite it a little bigger here. What does that 4 in the hook do if I want to... So we're not doing negative powers. Forget about the negative stuff for a minute. We're kind of changing gears and going back to the fractional power thing where the denominator to hook or hook to denominator, back and forth, changing between those two. There's 2 different rules. There are 2 different rules we're working with here. There's the negative powers are unhappy, jump to the other side, become positive. But now we're switching back to the numbers in the hook can go back to the denominator. And what's in the numerator? Yeah, there's nothing, so 1, right? Because there's an invisible 1 there. That 4 swings back. So it's x to the 1/4. Then the root vanishes when you do that because you change out of root form into fraction power form. And that's the answer they want. Where's that answer? D. Yeah, there it is. Is that good? Keeping those 2 different rules straight? So, in the root, in the hook, to denominator. Denominator, hook, back and forth. All right? How about this one? Now, we don't have any... negative 5 over 1. They're just trying to fool us. That's just negative 5, right? Don't worry about that over 1. Dividing by 1 doesn't do anything, right? Any number divided by 1 is just itself, huh? But now we can't leave it that way because they said positive, please. Please only positive. So how do you change that now to a positive power? It jumps. It's negative. It's unhappy where it's at. It's going to jump to the new jump. Now, is that negative power on both those guys? On the 2 and the x? Or just on the x? Just on the x. So he's only taking the x with him when he jumps, right? Only this is going up, huh? So it's x to the positive, and the 2 stays down below. Hey, I don't know why they put the 5 over 1 back in there. Whatever, that's just weird. It's just 5. But anyway, they're being weird. So, we good there? That makes sense how I did those rules? Those are tricky little rules, but you can get the hang of it with enough practice, huh? So negative powers just jump to the other side and then become positive. Numbers in the hook go to the root. Hook, root. What? Wait, it's the same thing. Hook, denominator, back and forth. All right. Do this question. Let me remind you about powers and how they work. Do you remember like 5 to the second? Well, here, let me just do it with an x for stuff. Remember like x squared times x cubed. That's x to what power? Do you remember that rule? Fifth power. Yeah, remember you add the powers? That's because x squared means 2x's, and x cubed is 3, so we have 5 total, right? Yeah, so remember when you have same bases times, powers actually add, don't they? So that's what we have here, huh? Same bases times, what am I actually going to do with those two powers? Add them. So you just keep the base, 5, and I've got to add up the two powers like that. See how that's the rule? You just make one base, same base, add the powers. Now, how do I add those powers? 3/5 and 5/10? Common denominator. Add fractions, you got to get common denominator. Let me get this out of the way. Is that good so far? So two same bases times, you just keep that one base, add the powers, and then to add that, top and bottom by 2 there, right? Remember that? So that'll be 5 to the power, of 6/10 plus 5/10, which is 5 to the power 11/10. And there we go. 5 to 11/10. And that's all they want on that one. How about number 22? Here we have same bases divided. Do you remember, like, if you have x to the 7th over x squared, when you have same bases divided, what do? Subtract, x to the 5th. Because they cancel, really. I mean, it's, what is x to the 7th but 4, 5, 7 x's, 2 x's. They cancel and you're left with 5, Right? That's why. I'm just giving you the reason why that rule is true. So, we subtract those. So you just put a single 3, right? When you have two bases that are the same, divided, you just put one of them, and you subtract the powers. And what's that, 2/10? And that's 1/5? Yeah, I see I just reduced the fraction there. On that last step, I just divided by 2, top and bottom, just to reduce that fraction. So same bases multiplied, you add the powers. Same bases divided, you subtract the powers. Rules I think you already know, but they just put it in a weird looking situation. It's a lot of power rules. So here we're gonna it's the same thing, right? We're gonna subtract those powers. But really I would first get a common denominator in those powers. Let's do that. So do you know what I mean? I'm gonna multiply top and bottom of this one by 7. Top and bottom of this one by 4. This one will be, you should use calculator if you're rusty on some of those times tables. 35 over 28, and this one is what? 24 over 28. Yeah, so it's the same thing, huh? It's the same thing. I thought it might be something different. It doesn't. And now you just, what do we do with those? Subtract them. And you keep the base, don't you? So just keep one same base, and then just subtract the powers. 35, 28 minus 24. Subtract, what is that, 11? 11 28. Same rule? Just getting comfortable? I'm getting ready to shift to the next section. We got to do one more section. We got 45 minutes. We're almost done. What do you do? They're pushing us on another rule here. What do you do with this? Think about if you had like x squared cubed. But you remember you actually times those. It's actually 2 times 3, meaning x to the 6. Why? Why do you suddenly multiply? Well, it's right, I can prove it, because what is x squared? It's 2x's and then all cubed. Isn't that what it means? Isn't x squared 2x's and then third power 3 times? How many x's you got? 6 of them. So the difference between this and the other rule, this is a single base with powers to powers. You multiply. Whereas, like all the ones we've been doing up to now are 2 bases, powers add or subtract, but 1 base, 2 powers multiply, don't they? They multiply in this case. So you multiply. So basically this is going to equal, keep the base, 5, and then you take the 7/4 and the 2/5, and you times them, which becomes what? 2 times 7, 14, 4 times 5, 20, and then we can reduce that. I could have just cross-canceled, that would have been quicker, but either way is fine. Hit divide by 2, top and bottom, and I get what? 7/10. 5 to the 7/10. All right, I'm going to skip 25. If you're okay, it's the same thing. Just get common denominator, add those powers. We okay? Am I going too quick? Is that, these last ones making sense? So, see the difference in the rules? So on 25, there's 2 bases. So you add the powers. 24, there was 1 base. 2 powers multiply. So the difference about when we add powers, if they're each have their own base, and if they're both on the same base, I think 24, we multiply those powers, don't we? So basically, maybe I could say the rule more simply. How about this? I can do it better. Powers outside parentheses multiply powers inside parentheses. How about that? That's the rule. Powers outside parentheses multiply powers that are inside parentheses. Powers outside multiply powers inside. So that means, so that's what we just did here in 24, right? This power outside multiplied the power inside. So powers outside parentheses multiply powers inside. And then 26, it's going to be the same thing. This 5 is going to multiply and multiply both those powers, isn't it? Everybody good there? Powers outside parentheses multiply powers inside parentheses. And that 5, what do we do when a whole number like 5 is interacting with fractions? How do you make that 5 look like a fraction? 5 over 1, huh? Just make it 5 over 1 as it interacts with those guys. So that'll become 3/4 times 5 over 1. And the other one is b to the power of what? 3/10 times 5 over 1. So that 5 over 1 multiplies both those powers, right? Powers outside parentheses multiply powers inside parentheses. So what do we get then? This is a to the 3 times 5 and 4 times 1. What's that? 15/4. And b to the 3 times 5, 10 times 1, 15/10. And then I can reduce one of those fractions, can't I? Divide by 5, top and bottom here. So this will become a to the 15/4, b to the, what is that, 3/2? There's our answer. Was everybody good with those? All those rules? A lot of rules, huh? So negative powers jump, they're unhappy, and they jump to the other side, then they're positive. Numbers in the hook can go back to the denominator, denominator hook, anytime you want. And then powers outside parentheses multiply powers inside parentheses. A lot of rules. So keep them all straight. Questions on that one? Yeah, Vincent.
Why do we have to divide by 5?
Oh, we always reduce fractions anytime we can. So anytime there's a number that goes in the top and bottom, we always do that. All right, good.